In this lesson, we'll simulate a toolpath. After completing this lesson, you'll be able to use Simulate to validate tool motion. Let's carry on with the file from our previous example and let's learn how we can simulate a toolpath. So far, we've set up and created a waterjet toolpath for our part, but other than the lines on the screens, we really don't know how this toolpath is working. So we want to simulate this to make sure that we can validate the tool motion, making sure that we're cutting all the geometry before we ever send it out to a machine. To do this, we want to make sure that we have the entire setup selected, or at least the specific toolpath we want to validate. Once done, we want to go to Actions and select Simulate. Also note that Simulate is one of the default icons at the top of this list. Once we select Simulate, there are a couple options that we have on the right-hand side of our canvas. We can show the tool, we can change it to just the flute or jet to show the shaft of the tool, or the holder and head. This will change based on what kind of machine or tool we're using. In the case of a water jet, if we want to see it, we need to have the holder and head turned on. We can also make it transparent if we need to see through it to see some of our geometry. For the toolpath, we can turn on Show Points, which will show very specific changes in direction, and you can see all these on the rapids. We can also change the mode of which it's displayed. Right now it's all toolpaths, but we can change it to show the tail, which will only show where the tool has already gone. And if we turn the tail option on, you can see that nothing is currently displayed on the screen. Now we can also turn on stock, and this is a great option as well because it allows us to specifically see our starting point, in this case the green amount of stock that's oversized for our part. We can change the mode. We can also change the colorization. In this case we've got one toolpath, so it won't really matter, but if we had multiple toolpaths and tools, we could change it to show which areas were being machined by which tools. We can change the display of it. For example, we can make the stock metallic paint or ceramic or mirror. In this case, we're going to leave the plastic vinyl. And we can also increase or decrease the quality. Lastly, we can turn it on transparent. If you want to hide the original model, we can also turn that off in the browser, so we're just looking at the stock. Then we can turn the transparency back off. In order to play this, we'll have to go down to the bottom center of our canvas area, and we can start the simulation. We can change the speed and direction by moving the slider around, and we can also jump to the next move, the next operation, or all the way to the end. We're going to set the speed slider somewhere in the middle of the section from the right over, and then we're going to hit play. So now you can see that it is showing the tail of the toolpath as we're moving around. We are seeing the rapid movements. We're seeing all the cutting movements. You can see that it jumped up and moved over because of the distance it had to travel between those. And then it's going to cut the entire outside profile of our part. If we want to speed it up or slow it down, we can use this option. And again, if we go past that center line, we can actually play it backwards if we need to. Or we can use some of the other navigation options to simply jump all the way to the end to make sure it's been cut. So having this play back with the simulate option, we can see that as it goes from these larger pockets, it's actually lifting up and jumping over. If we wanted to keep the tool down, we would need to go in and modify this toolpath. So we're going to right click on 2D Profile and select Edit. Inside of here, in our geometry section, this is where we selected all of our openings. We have our height section, which allows us to dictate where the tool is going to move up to. And then we have our passes section, which allowed us to control some tolerance values, whether or not we were leaving stock, and whether or not we wanted additional smoothing tolerances. And lastly, we had our linking parameter, in which we could control if we wanted to keep the nozzle down. So I'm going to increase this maximum stay down distance to 150 millimeters. Then I'm going to allow it to recalculate that toolpath. Now that it's been recalculated, and we rotate this around, you can see that the tool is no longer jumping up here. We can validate that by going to Simulate, and we're going to go ahead and play through. So as we get to these larger pockets, what we're looking for is the distance that the tool actually moves when it's going between those large pockets. We want to see if it jumps up, or if it stays down closer to the part. And we can see now with that increased distance, it keeps it down closer to the part. So everything looks good here. We were able to cut all the geometry. We can see the lead in and lead out cuts in these areas. So this tells us that the tool is on the correct side of our cut. We have the right amount of lead in and lead out, and we're cutting the entire outside as the last operation. So since everything looks good here, we can go ahead and close, and I'm going to navigate back to a home view. And before we save this file, I just want to make a couple more quick notes. If we expand the 2D toolpath inside of the browser, you can see that it shows the WCS, which is the same for the entire setup, as well as the size of the toolpath itself. If we right-click on the toolpath, we can edit the tool. We have some other options such as compare and edit. And then down here we have our options to generate the G-code, which we'll talk about a little bit later in this course. We can simulate it from here rather than going up to actions. We can post-process. We can create setup sheets and clear the toolpath. We can also take a look at things like machining time, make defaults, which will take all the parameters we have in this toolpath and set them as a default. And then again, we've got several other options that we can see down here. So we're not going to talk about all of these right now, but I do want to point out the machining time. If we select this, it'll show us that we have a specific amount of rapid feed movements, the amount of time it takes to change a tool, for example, and then we have the distance in which we're feeding and the total feed time. So you can see for this specific part that the total feed time is a little bit over 2 minutes. The number of tool changes is 1 because again we're just using a single water jet nozzle, and we have a total machining time of about 2.5 minutes. So this is again great information for us to take a look at to understand where we're at in terms of the efficiency of our toolpath and whether or not changes like keep tool down make a big difference in the grand scheme of things. From here, let's make sure that we save our file before moving on to the next step.